In this video, I'll be talking about mutually exclusive events. So let us consider event A and B of the same experiment. So event A and event B of the same experiment. Let's say A is the probability of obtaining a head, is the event of obtaining a head, and B is the event of obtaining a tail when we toss a coin. So let's say if we toss a coin once, so you find that the probability of us, you find that if we toss a coin once, we cannot get a head and a tail at the same time. So if we toss a coin once, it's either we get a head or we get a tail. These events, obtaining a head or obtaining a tail, these events cannot occur at the same time. So these sort of events are called mutually exclusive events. So they are called mutually exclusive. They are called mutually exclusive events. So mutually exclusive events are events that cannot occur at the same time. So let us look at another example. So let's say with one throw of a die, we cannot score a 3 or a 5 at the same time. So let's say event A is scoring a 3 and event B is scoring a 5 when a die is thrown. So let's say if we throw a dice once, if we throw a die once, these events, we cannot obtain these events at the same time. It's either we obtain a 3 or we obtain a 5. These events cannot occur at the same time. So these are called mutually exclusive events, A and B. So let us take a look at event A and B in set form. So let's say this is the whole set. So this is event A, and then this is event B. This is event V. So you find that in mutually exclusive events, these events cannot they do not intersect, because these events cannot occur at the same time. It's either we get in event A or event B, but they cannot occur at the same time. So the probability of the intersection between A and B is equal to 0, since these events cannot occur at the same time. Since these events cannot occur at the same time. So for mutually exclusive events, the probability of event A union the probability of event B is equal to the probability of A plus the probability of B. So this is also known as the addition rule. So you should keep that in mind. For exclusive events, this is known as the addition rule. So the probability of A union B is equal to the probability of A plus the probability of B. Or it's also known as the OR rule. So we can also say the probability of event A or the probability of event B is equal to the probability of A plus the probability of B. So you should memorize these rules for mutually. Sorry, this is the OR rule. For mutually exclusive events. mutually exclusive events. So let us take a look at an example. Let us take a look at an example. Let us solve mutually exclusive events. So here I got two questions for mutually exclusive event. So the first question is, a card is drawn from an ordinary pack of 52 playing cards. So we know that the total number of cards, or in this case, is 52. We are told that a card is drawn from an ordinary pack of 52 playing cards, and then find the probability that the card is a club or a diamond. So we are told that, so the question says we should find the probability that the card is either a club or a diamond. So if you still remember, we said for mutually exclusive event, this is the oral rule. So that simply means that the probability of getting a club or a diamond is equal to the probability of getting a club plus the probability of getting a diamond. So if you know how to play playing cards, you know that there are 13 clubs in total. So there are 13 clubs in total, and there are also 13 diamonds in total. So there are 13 diamonds in total. So in this case, the probability of getting a club or a diamond is equal to the probability of getting a club, which is 13 divided by the total number of cards, which is 52, plus the probability of getting a diamond, which is 13 over the total number of cards, which is 52. So if you divide this by 1, this is 1, and then this will give us 4. This is 1/4, then this is 1/4. So you find that the probability of getting a club or diamond in this case is equal to 1/2. So this was an example of a mutually exclusive event. So let us take a look at the second part. The second part, the probability a king or a club or a king. So the probability of getting a club or king. So this oral rule tells us that these are mutually exclusive events. We cannot get a club and a king at the same time. This does not happen. So this is an example of a mutually exclusive event. So which is equal to the probability of getting a club plus the probability of getting a king. So we know that the total number of kings in a pack of cards is 4, and the total number of clubs in a pack of cards is 13. So the probability of getting a club or a king is equal to 13, which is total number of clubs, is equal to 13 over 52. That's 13 over 52, plus 4 over 13. So in this case, this is 1/4. So this should be 52. This is 1 over 13. So that's 1/4 plus 1 over 13. So if we solve with the common denominator in this case is 52. We divide 4 into 52, that's 13 plus 4. So the probability of getting a club or a king in this case is 17 over 52. So let us take a look at another example. So the question is, in a race in which there are no dead hits, the probability that John wins is 0.3. So let us so the probability that John wins, so probability that John wins is 0.3, and then the probability that Paul wins is 0.2. So the probability that Paul wins is equal to 0.2. And then we are told the probability that Mark wins is 0.4. So the probability that Mark wins is 0.4. The probability that Mark wins is 0.4. So find the probability that John or Mark wins. So the probability that John or Mark wins. So I want you to take a note at one thing. So John and Mark cannot win at the same time. We will only have one winner. So it's either John wins the race or Mark wins the race. So this is also an example of a mutually exclusive event. So probability that John or Mark wins is equal to the probability that John wins plus the probability that Mark wins. So the probability that John or Mark wins is equal to 0.3. Probability that John wins is 0.3 plus probability that Mark wins is 0.4. So the probability is 0.7. So we have solved the first part. So the probability that either John or Mark wins is 0.7. So let us take a look at the second part of the question. So John or Paul or Mark wins. So the probability that John, Paul, or Mark wins. So let's say if they are competing in a race, if these three are competing in a race, we can only have one winner. It's either it's John, Paul, or Mark. We cannot have John, Paul, and Mark win at the same time. There can only be one win. So this is going to be the probability that John plus the probability that it will be Paul plus the probability that it will be Mark, which is equal to be that John, so I'm just going to write it in short form, or M wins which is equal to 0.3 plus 0.2 plus 0.4, which is equal to 0.9. So that is the probability that either John, Mark, or John, Paul, or Mark wins. So let us look at the third part. So this is so the third part says someone else wins. So let's say if there are 4 competing, what is the probability that someone else will win? So we know that the total probability is equal to 1, and we know that the probability that John, Mark, probability that John, Paul, or Mark wins is 0.9. So what is the probability that someone else wins? So the probability that someone else wins is equal to 1 minus the probability that John, Paul, or Mark wins, since we know the probability that either one of these 3 will win. What is the probability that if there are 4, someone else will win? We subtract by the probability that either John, Paul, or Mark wins, which is 0.1. So this is the probability that someone else will win. So thanks for watching, guys. I hope this video helped you understand what are mutually exclusive events. So if you have not yet subscribed to my channel, please subscribe and turn on the notification bell on so that you do not miss any of my videos. Thank you for watching, guys.